Hello. Our senior design project is the electromagnetic pulse mitigation of substation enclosures run through the electrical engineering department here at Michigan Tech. This project was sponsored by System Control. System Control is one of the primary manufacturers of substation control enclosures in the United States. A growing concern is that an electromagnetic pulse, or EMP, could cripple our power and communications infrastructure. An electromagnetic pulse occurs when a nuclear weapon is detonated at high altitudes. This blast creates a very large electromagnetic field that has the potential to damage critical pieces of industrial infrastructure. Our task as a design team was to come up with a method of testing substation control houses for their ability to mitigate this electric field.
Our process began with getting a clear understanding of the report published by the Electric Power Research Institute, or EPRI, on high-altitude EMP. The study details the frequencies, 10 kHz to 1 GHz, that such an attack would produce, as well as the necessary attenuation, 30 decibels, that a substation requires to protect the power grid.
The IEEE 299 standard and the military standard were the two primary sources used to develop our project's testing procedures. Additionally, these standards gave us insight to what equipment we would need to perform these tests to measure the attenuation these enclosures provide.
To conduct the test, 3 types of antennas were used to measure attenuation. For mid and high frequency tests, biconical and log periodic antennas were designed and constructed. The construction of these antennas was done since the money to purchase them was not in our budget. Small loops antennas were also purchased to test the low frequency range. To accurately measure the antenna signals, a network analyzer was used since its ability to measure both the transmit and receive signal at the same time.
Using the previously mentioned standards and the equipment source, 2 separate testing procedures were created. The first was created to perform a building characterization and involved testing over 310 frequencies. This test was designed to be performed on each new enclosure type. The second procedure was created to test enclosures at the end of line and only involves testing at 10 frequencies. The testing we were able to complete was conducted in the EERC and involved using the procedures previously mentioned. The team followed the building characterization procedure, which involved using a network analyzer to transmit and receive an electromagnetic signal. First, the measurements were made with no obstruction between the antennas, and then measurements were taken with the wall in between. Using both sets of data, the attenuation of a wall can be obtained.
The results of the tests are shown on the left of the slide. The first one on the left is an open air or baseline test with no obstructions between the antennas. The next graph shows the attenuation with the concrete lab wall between the antennas. The average attenuation being about 5 decibels across the range of the antennas, which is very close to the results found in the EPRI study. The final graph shows the VSWR characteristic of the biconical antennas, which was used to validate how well the antennas operate within their design frequency range. Due to the campus lockdown, the project has 2 different paths for the future. The first one is the project being continued with a different senior design team next year and extending the goals of the project, which will be determined with the cooperation of Systems Control. The second path is for the project to be taken up by Systems Control, and with all the information the team can provide by the end of the semester, carry on the project themselves. The tests conducted and procedures generated during the year will serve as a valuable starting point for the power and communications industry as they move forward towards future EMP mitigation strategies.